Hey folks, welcome to another week of Yugabyte Friday Tech Talks, YFTT. Welcome everybody. These are, a technical series of talks. Again, so you can feel, we talk about like the design, the usage of pretty technical things as it relates to YugabyteDB and distributed SQL in general. If you have questions, as always, just drop in a comment on the LinkedIn comment thing, and we will get right to it. And if you can also connect with Bryn and the rest of us at our community Slack, yugabyte.com/Slack, and you can specifically go to the YFTT channel. Anyway, so today's episode is going to be quite interesting. It's the infamous "Are stored procedures useful?" topic, and we have an excellent speaker in Bryn. Like Bryn often packs a lot of information with a lot of humor at the same time. So coming from the Oracle world, quite knowledgeable about the world of relational databases. So I'll let Bryn do a better job at introducing himself. So maybe a couple of minutes to just intro yourself and your background, Bryn, and we can get this rolling.
Right, I'll share my screen.
Yeah,
I believe now is the moment.
Now is the moment.
And this is the title, thought-provoking, but of course it's a no-brainer. Yes, the spoiler, yes, procedures are a good thing, as I will convince you, I hope. Karthik, you did what I said don't do. You said it's by engineers for engineers. I should make it crystal clear that I'm a meta engineer.
That's fine. That's okay. It's still an engineer.
Don't do it. I have done it. I've written C programs like other people, but not these days. But I've been in this stored procedure space for a long time. And I will just mention one thing at a higher level before I get into it, and then I'll say more in that space. This happens to be a link, not that it'll do you much good unless you get the slides, but it's not hard to remember this. I was interviewed on this thing once, and if you want to know my whole dull history, you can check it up there, and it's got my LinkedIn, my Twitter, and a link to all the blogs on Yugabyte that I've written, and that's enough for that. Now we can really get into the stuff with this, a little history lesson. When did these things come about in relational databases? And they were first supported in the late 1980s. And back then, there was no open source. All there were things you could buy. And then it happened to be, the names you heard were Sybase and Oracle, of course, and this thing, DB something or other from IBM. And, yes, it's funny how they're still on too, but never mind. I was working then, and I was on a project team who were going to design a whole brand new system, having done its requirement analysis for information handling in the hospital. It was back long before the internet and all that stuff, but they did have what they called distributed computing, and you always heard the name RPC when one computer did something and asked for some other computer to do something to help it get there. And when we needed to select a database, we were dead keen on this RPC thing. It was the fashion, and Sybase had it. Of course, RPC was just another name for stored procedures. Because excuse me, swallowed my coffee. Long story short, Oracle didn't, Sybase did, and we chose Sybase. And then a couple of years later, Oracle brought them in, and I was lucky enough to go on a course. I was sent up to the north of England in a scenic spa town to learn all about create or replace and blah, 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 blah. And the question is, of course, why did people say they did it, apart from if Sybase has got it, Oracle has got to have it? And what you heard was run authority and phrases like ownership of responsibility for correct SQL and atomic, you hear this word all the time, guaranteed atomicity for multi-statement transactions. It's all to do with who's got the authority and knowledge to do what, and as well, a bit of a performance angle, round trip stuff. I'll expand on these points as we go along, but basically, if you don't use stored procedures and you want to do stuff, well, you're doing SQL, whatever it might be, right there from the client, and it's got to be able to see and touch the tables. And unless every single table has a different owner, which I've never seen in my life, then typically they all have the same owner. The client connects as that owner and can do anything to everything. And then it's up to the client code to in some way regulate it so that end users don't get to do wrong things. And the people who program that are busy programming UIs and everything as well. There's no splitting of duties and so on. That's what this is about. So that's the background. It's a long time ago, 2020 minus 80, if I can do my sums right, is 50 years. So then let's just scrape a bit more in that area with some ancient wisdom. This is nothing to do with anything specific. It's one of the generic things you hear. And I heard it when I first started typing if then else in real anger right at the start of the 70s. And people there were telling me this stuff as if it wasn't obvious and making sure I honored the principles. And large software systems are complicated, obviously, and they have to work and you have to understand them. And the only way to conquer that is by some kind of hierarchical breakdown into components, subcomponents, and so on. And the word module is always used for the items in that breakdown. And if you've got any kind of system that uses at least one SQL database, and many systems use more than one, and there's all sorts of client code going to this one and that one, but by any ordinary common sense thinking, a particular SQL database is a module. And it's no less of a module when it's a current modern one like YugabyteDB, in other words, a distributed SQL database system. So that led to a notion, hard shell paradigm, and some consequences. I've maybe preempted what I was going to say, but I like this phrase, result happiness versus result misery. It's a quote from David Copperfield back in 1850 about looking after your money, but it's applicable in many areas. Now then, this was what I was just saying. To stress it then, a SQL database in any system that uses at least one is most certainly a module. Ask anybody in our general space to say what a module is, and they can't get halfway into the first sentence before they've said things like encapsulation, like coherent functionality, like API, like exposing the functionality, like hiding everything behind the API so that all the users of that module know about and need to understand is that API. That you hear that in so many different places, so many times, and I keep on asking, oh, do people think that's rubbish these days then? And no one challenges that. That is the paradigm that reigns over all others in software engineering.
Yeah, kind of common to programming languages as well, right? Like a lot of this.
Oh, is it anything, absolutely everything at all. Yeah. So as I stressed, any relational database in a system with two or several is a module. I can't see how anyone can argue it's not. They can't argue that some lump of heterogeneous stuff, something implemented in some client framework together with the database that it uses, jointly are a module. That's just counterintuitive, counter common sense. So what then are those things that map to the general notions? Well, surely the structure of the tables, their names for that matter, all the rules that constrain their rules, all the SQL statements that actually read and change them, the stuff that is the essence of SQL, that is the implementation. It's the details of the implementation. The SQL isn't a way you might express an API. The SQL is all about the nerdy internal nitty-gritty details of the implementation. Now you want an API. What should the API actually model? It should model the things the database has to do in business terminology, like create a new order with the items that go with it. And you can imagine that when you say it that way, it's easy enough to characterize it as the facts about one order and the facts repeating about each of several orders. And that's all the API needs to understand and then do the job and report back if it succeeded or if something went wrong. Yeah. And all that can be done in a completely SQL independent fashion. And Postgres, and therefore MySQL, which I'll convince you in a heartbeat, are indistinguishable in the space of what I'm talking about. They provide subprograms in SQL and in a if-then-else language that's called PLPGSQL to express the API. Well then, this is the thing that I like to call the hard shell paradigm. I didn't invent the word hard shell. It's another thing you hear all over the place as a kind of metaphor for the encapsulation of a module. So I'm saying use stored procedures to encapsulate the entirety of the SQL database's functionality behind, and it has to be impenetrable to be worth it, behind an impenetrable hard shell API. I'm going to say stored procedures all the time, but I hate the term. I much prefer to say subprograms, in other words, functions and procedures, whose definitions are stored in the database and that execute, and this is key, in the very, very same process that the top level SQLs themselves execute in. Okay, so there's no switching between different CPUs or any of that business across networks when a stored procedure, as I'll have to call it, does a bit of SQL. It's all right there in the one process. That's the hard shell paradigm. And believe it or not, some people just say no. So there's another one, what I call the bag of tables paradigm, which starts with the motto, we don't use stored procedures. Why? Oh, blah, blah, lock-in, oh, blah, blah, can't get the programmers, oh, blah, blah. Oh, it's not object-oriented, blah, blah. And the manifestation of that is all the tables have a single owner. They all live in a single schema, client code coming off this here framework that no one quite understands what it's doing because a lot of the SQLs are generated. It can change and read all table content without restriction, and it can even drop and create tables. And that means that anyone whose job is an engineer in that client-side space can be unscrupulous and can get hold of all sorts of stuff that they should not. And I'm sure you've heard that most of these evildoers actually do their evil because they're on the staff, because they're trusted. So those are the two opposing things. And I've spoken to more people than I've had hot lunches at various conferences about this space. And some of them, it's clear, they're following the hard shell paradigm. They're mainly happy with their apps. They express themselves coherently and they explain well how everything is done. And then they ask clear questions and maybe they make sensible requests for enhancements in the general space of SQL and stored procedures, everything inside the database. And those who follow the bag of tables paradigm, I can tell them in a heartbeat that they're largely miserable. And what's worse, I just can't understand what they're banging on about, because in one sentence, they'll be talking about various Java notions, all sorts of networky stuff, and a bit of order by or group by and so on, all in the same sentence. And you just have to find a way to walk away. So then that's the background. Now I'm going to move into the concrete.
I think there's one thing that's in the previous diagram that's just suddenly hitting me as I was seeing this, is that like even in the bag of tables paradigm, I think those that do write, complex programs, but that are easy to maintain, they still follow the hard shell paradigm, except it's SQL plus application level language code abstracted away as good functions, right? So it's still followed just at a higher level, right? So,
well, yeah, but that's a contradiction in terms, Karthik, because those people now whose concern spreads all over the place.
Over the place. No, I agree with that point. Yeah, I agree.
Have the opportunity to do evil things in the database.
Yeah, but
and they need to be a bigger team, and the risk is higher. If you have one focused team whose only job is doing everything to make the hard shell present and do what it should do, then they're a smaller, more manageable team. You can keep them under closer scrutiny. Security is better. It's as simple as that. If you needed a colonoscopy, would you go to a gynecologist? I mean, I'm sure they've had the same general training, and with a bit of an effort, the gynecologist could get the job done, I suppose. But, in other disciplines, we recognize that there's a division of skills, and responsibilities and training and everything, and so is there in this space if you want good results. So now I'm going to move to my pictures. This is what you get in YugabyteDB if you create a brand new database. Inevitably, it starts life with a public schema where any user who can connect to that database can just create stuff. That's the last thing you want to happen. So just get rid of it before you do anything else. Now we have a virgin space in which we can set up the environment that we want and make sure it is exactly and only that. And the first thing we're going to do, against the background of using notions in the database for ownership and location classification sensibly, we're going to create, I'll call it user, but the official word is role, data, who will own the tables and the indexes. And data, the owner, the user, will have a schema of its own for the purpose of classification. I've drawn the schema as a blue box. It could have several if that makes your own notions of, subunits of functionality hang together more coherently. And then next thing is we'll have a different owner for the code who then can't actually connect, if you do this full on, because he doesn't know the password, to the other schema, but the owner of the data will have made sure that the owner of the code can see the tables for select, insert, update, and delete. That means, by the way, that anyone who authorizes as code can't drop the tables or create anything else, can't mess up the actual database design of all this information side of things. All they can do is do stuff through the procedures they write. And then I've drawn several boxes here to show that it might suit your purposes to have several schemas. That's not the main point. The main point is the ownership. Moving on then, here now is a kind of a shim, as we call it, just a few subprograms whose job is nothing other than to invoke the ones of these who are the real intended API endpoints. And the point is, of course, that there's gazillions of helpers floating around that have no business being exposed to the outside world. And you can achieve that without this API schema just by grants and things like that. But doing this, it just materializes your notions, so it's so easy to see, and it is not in any way harmful to performance or anything. And then finally then, and this is key, I've drawn a white box there as a metaphor, but the database role client owns no schema. All it is the target for grants, and it can execute these procedures and do nothing else at all. And that means that someone, and this will be the outside world, the people with their frameworks and so on, who connect to the database to run their framework code, which in this case, framework is the wrong word perhaps, all it's going to do is call procedures. All it can do is store procedures, because when you authorizes this and you try to do anything other than that, apart from select from the catalog, you will find out that you get a privilege error. And this is very much an intended and first-class regime. So then, here we have what the outside world sees. So I'll slip that to the side. And this is the outside world. And there they are. They can do whatever they want, only and if it's what was intended. And you might find it useful to have more than one set of stuff, some for human consumption, some for robots. Again, that's a subtlety beyond the main point. So then, here's just a little cautionary tale. I was happy to find that this happened in Oracle. It happened to me, and I'd screenshot it instantly. I was trying to do something innocent through one of their customer-facing apps, internet-facing apps, and I got this. Blah, 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 in French, believe it or not. And the subtext of all that lot is some engineer generated a stored procedure dynamically on the fly, and it had a syntax error. That should never, ever escape to the user interface. And that's the motivation for me getting to this point about expressing the API as a set of JSON in, JSON out procedures. So the client-side environments, they all have different type systems. You know, SQL's got one thing with its special meaning of numeric and money and all that stuff. And client languages try to do the same thing, but they have subtly different semantics. And this is why JSON came about, so that you could normalize, squish everything down to text and reinterpret it in the best way that's meaningful on the receiving side. And all modern client-side programming languages have just built-in functionality that makes it trivially easy to transform in each direction between an arbitrarily complex compound value as it might be expressed in the primitives of that language into JSON. They call that serializing it. And then you can go back from such a JSON representation, in other words, parsing it or understanding it, into the complex compound object that it represents in that language, or correspondingly in any other language, as long as you can establish a reasonably sensible mapping between the notions. And of course, YSQL inherits from Postgres such a set of native functionality for doing that stuff, like other languages do it. And the absolutely natural, easy, and best choice for parameterizing the API is this, in the hard shell paradigm, of course, is a JSON in and JSON out procedures, okay? And, you know, who knows how they're going to get invoked? You could, in a Python program, just do the call statement directly, but these days people have, you know, servers who understand the REST protocol and have that coming in, and they translate it into database calls so that that's all localized too in its own module, using that term again. And so you could invent some REST protocol, where the names of the procedures are verbs in this whole REST world, but the payload that expresses just what should be done, or that sometimes comes back from a REST request, it's got to be expressed some way. And if you do a bit of Googling, you find that JSON happens to be the overwhelmingly popular protocol. There are others for that. Okay, that's a nod to 1066 and all that, a memorable history of England, but never mind that. So then,
one question,
yes.
perhaps slightly more orthogonal to the JSON point specifically,
yes.
that Piet asked is YB data plus SQL processing is automatically distributed plus scaled. Can the execution of stored procedures also benefit from this automatic distributed scaling?
Ah, that's Pete to visit, my old friend. Hi there, Pete. Yes. Well, that's a question for you in a way, Karthik, if you want to take it. The short answer is yes, because once you're doing your SQL, it's the same story as anywhere else, and the SQL's got to get started somewhere, and there's not much difference between it coming into some node from the outside world and being in that node from a stored procedure. That's how I would put it. Do you want to put it differently, Karthik?
No, I think you got it right. I think another way of saying the same thing is that you could split, in the case of YugabyteDB, the SQL processing side from the data access and the lower half, right, the data processing side. And all of the nodes are even when it comes to SQL processing, which means you could enter the stored procedure execution from any node, as Bryn said. And based on where your data is split and distributed and placed at that moment of time, which is the actual, variables inside the SQL procedure that will access data and do the manipulation, it would go to the right nodes. Now, by virtue of the data itself being distributed, this processing, procedure over procedure call invocation with different input parameters and output parameters would, scale out that processing as well. And Pete also says hi back to you, Bryn. Yes,
good, thanks. So I would put that, as I attempted to, much shorter by saying SQL and stored procedures, or SQL and PLPG-SQL, or especially stored procedures written in SQL, it's all one thing. They're all processed, as I said already, in that one space. And I firmly believe that attempting to make a distinction, oh, I like SQL, but I don't like stored procedures, is absolute madness. It's like saying, oh, I like the ltrim function, but I don't like the rtrim function. It's just one space of understanding and one space of execution model, as Karthik just said. So then, on to this now. Why procedures, not functions? A bit of preaching here. Procedures and functions are different in the whole academy. A procedure does something. That's the whole point. It has an effect. You can hardly call it a side effect because it's the intention. It happens to be invoked with a call statement, and call, of course, is plain English for do this. It's named, if you're sensitive about naming conventions, with an imperative verb. Do this, change the other. you know, that kind of thing. But procedures can have out arguments, most critically, of course, so that they can report back some status. Now, a function, in contrast, it's just a name for a value that happens to be computed, but in all other ways, it's the same as a variable. It's like a variable who computes its actual value when you ask to read it. And it's invoked, therefore, as a term in a SQL expression. And when I say SQL expression, I mean an expression in SQL or in PL/PGSQL. And of course, it should be named like you name your variables. Price per unit or something like that with a noun phrase, just as you name a column or a variable. Of course, that doesn't stop programmers who only write code and see what it does, calling functions get something, but I can't help that tradition. When you're writing new code, you can at least be sensible here. And functions can have out arguments in Postgres at least, and therefore YugabyteDB, because of some history. But never mind that, it's an awful, nasty anti-pattern. So in the use case in question here, where we're always going to return a status having either changed something, really done something, or just read something, we need a procedure. Enough of that preaching. So that that was all this lot. Every subprogram might need to do something. Why am I so sure that a query might need to do something? Because something can always go wrong, like we saw with that French bollocks in that Oracle internet-facing application. And therefore, if the end user's not going to see all that gobbledygook, but someone is going to understand what went wrong and diagnose it, how are you going to fix it? You need exception handling in your stored procedure code, who will trap the famous others and then record every single fact that's there in the environment down in a table, get the ticket number that comes back from the surrogate primary key, and send that message back to the client. You know, unexpected error, ticket number so-and-so, and that's all the user at the seat sees. Of course, they would see a sanitized version of that. And the whole point then is that exceptions, in my book at least, should never escape the database except by this sanitization thing that I just mentioned. Okay then, and these unexpected errors, they're basically developer bugs. You know, you try to put something that's too big into a column where it won't fit and something goes wrong because the whole bigger apparatus of the design didn't do the checking much, much earlier on. In other words, in the UI code before it even got that far. Okay then. Now then, this isn't the use case. I'm getting short of time now. I don't know how well I can do in the meantime. It's the famous masters and details. I'm sure you recognize this stuff just by gestalting it in one eyeball. It's a masters table with agnostically named columns, a details table correspondingly named in the appropriate constraints. And this is the code that you use for creating a new details thing. At least it's one way of doing it, where the question is, how are we going to parameterize it? We haven't got to JSON yet. What we want to do is just call this procedure with all the facts, and the facts are therefore going to be the name of the master and an array of the, when I say name, I mean all the facts really, but here they are only names, and all the facts about the details. And once you're in it, you need to unscramble it. But the outside world doesn't care how you do it. And here's the junior, you know, the junior programmer's way. You insert something into the masters, what you got off what came in, you get the key that comes back, and then you loop through every element in this array, doing an insert, insert, insert till you're done. It's a famous anti-pattern, single row sequels in a loop. And there's another way, and it's this. This is a meta point. I'm not teaching about cross-lateral join, but even the phrase cross-lateral join makes you think, oh my God, this is hard, this is scary. What the hell? And unnest, what the hell is that? Well then, it's something to know. It's something that SQL experts do know. It's maybe something that people whose main job is UIs don't know, and they needn't know it. but you can take that into use and you can get this optimal expression there. I'll show it you one more time. This is the naive way, loop in row by row, every single insert a different statement. And this is the sensible way, where you just do one SQL statement who does the whole job in one bang, bulk SQL. Okay, so the whole point of that was not the detail, it was the higher point that different people know different things and you can't expect everyone to know everything, and therefore this division of job duties is sensible. And similarly, if you read it, there's a sensible way to read it by building up what you need to send back, which is an array, just like the thing that came in to make something in the first place, building it in one single SQL statement who uses this array ag thing. I think I've got time just to squeeze that in. If you want to know what the hell array ag is, you just go off to where's it gone now? Here, the docs,
yeah,
and stick it in there, and here it comes back, and here you are, and this is my handwriting, just so that I've said it. Okay, it's as simple as that, and it's not hard to understand. The hard thing to understand is that it existed in the first place and that there's a use case for it.
And right, a lot of these techniques you're talking about, Bryn, really actually help push up even performance and more than even just security and things like TPCC, right? I remember a lot of that effort using, a bunch of these type of techniques.
Oh, absolutely, absolutely. So then, this is the last thing. I hope I can squeeze it in before I might have done demos, but we'll have to take a call.
There's a question from Etter.
Yeah.
Is there a paradigm to choose correct version of the stored procedure depends on the version inside incoming JSON request, or should it be a manual job? He's talking about, okay, I don't know I'm not aware.
Oh, well,
PBR does it on the connection level, but in REST API paradigm, it should be a part of the JSON.
I think the simple short answer to that is all that can be implemented, but by ordinary common sense programming.
Inside the procedure, right?
To the extent that I've understood all this space, there's no automation for it, no implicit notions that you can do. You would have to use some discipline of schemas, like version something in one schema, version something in another schema, and then all the stuff would dispatch on that schema, which you would code in some ad hoc fashion. That's how I picture it. All right then, so just to show you what I'm talking about then, this is what the call looks like, and this is JSON now. You may or may not be able to read it fluently, but I'm just saying we've got an object at the top who is composed of a single key value pair that's a scalar, and then another key value pair where the value is an array of these guys. And you can see what it is. This is the facts. In this case, it's a scalar fact that characterizes the master to be created, and these are the facts that characterize the corresponding details. And you run it and you get success. Now, here's one where who knows how it happened, but the intended set of details have got internal dupes among themselves. And so you have a go, and what comes back is an error. It's just a funny thing about JSON that the order of reading these key value pairs is unpredictable. Well, you can predict it. It's based on a crazy rule of length of key and alphabetic sorting, but never mind that. No human being sees this. That's the whole point. The client is unscrambling this lot, and clearly they look to see what was the status. Oh, user error. What was the reason? Given that it was a status error, they look for the reason. Oh, I see. And then this is just, it could be a number that they have in a lexicon of bad things that could happen that's just got these as parameters. That's a detail, but I've just spelt it all out there. And then here's another thing. This is the programmer error. You stick in Christopher, it happens to be too big for the column in question. It should never have got to the database because the UI should be doing a better job. You don't want a ton of defensive code in the database checking it again. You want to assume it's right. But if it breaks, catch that as an unexpected error. And then this is what the support engineer sees. All the information you need to understand, oh, someone sent me something too wide. I'll just write a quick email to the idiots on the client side and get them to do the right job. That's how this whole paradigm works then. And then
one question, another question, Bryn. I think this is probably a a simple answer, but do inserts done by the stored procedure have to be committed by the caller after the stored procedure is done, or can it do its own commit only for the data that is changed? In other words, he's asking, does Postgres have the equal
yes.
Pragma autonomous transaction?
Right, it's 10:06 now, and
or maybe just
asked me that, so you've given me license to answer it. So here goes.
Frank just answered it, so maybe they were okay. He's saying there's
well,
no.
If you type it, it's not the same. But thank you, Frank. I'll give my version of it. If you come from Oracle and you're very used to it, and then you start to do stuff in Postgres, and therefore it's the same in Yugabyte, you will have a shock. No matter what people say about SQL is SQL and standard and so on, there are vast differences in important key paradigms. And one thing about Postgres is that the whole paradigm is to run in what they call auto commit mode, which means anything you do, like a single insert, will just do it and commit it. Of course, you can overwrite that, and people who are doing client-side stuff use explicit start transaction, blah, 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 finish, that kind of thing. But the key point now is that Postgres, I'll say Postgres all the time now to save breath, is designed so that any stored procedure call, and this includes an anonymous block, by the way, implicitly starts a transaction and implicitly commits at the end, or well, in fact, if anything goes wrong, commit and rollback are indistinguishable in this case. So you have no choice. And though commit and rollback are sort of allowed in stored procedures, it's completely unlike Oracle. You never do that. You'll get into trouble if you do, unless it's some super edge case use case. You just write what you intend and let it happen. And this is absolutely gold dust. It's hand in hand with the paradigm, because the paradigm is you encapsulate a multi-statement transaction, which models a single business purpose transaction, but takes many SQL statements. You model it by implementing a stored procedure who necessarily, therefore, behaves atomically with respect to the overall outcome of that. So you never think about this whole business of commit, ironically enough, and you never need this notion of autonomous transaction. How do I get stuff in a table, and how does it not harm anything? Obviously, because when something went wrong, there was a behind the scenes rollback, just as, by the way, there is in Oracle, that I didn't spell out myself. And then I'm in a fresh start, and I can insert into my table of incidents. And again, I don't actually spell anything. I just do it and I'm done. And then that is committed instead of all the harm that I discovered I couldn't do, which got rolled back. So I hope that answers the question. The summary is it all works out remarkably nicely, and you don't have to think about details that sometimes you're obsessed about in Oracle. I remember blog post wars about, oh, Tom Kite says procedures should never commit. Oh, no, I didn't really see. Oh, on and on and on and on. Right then. So this is the report now. Here I'm asking for the details of Mary, and what comes back, I get a status success, and I get this structure, you know, this value here, which itself is compound, where it has a key value scalar thing for Mary and an array of the details. Simple as that. And of course, you parse this easily enough client side and translate it into what it means in your data structures. Now, if you go in with Bill, and of course, Bill's not there, we consider that to be a user error, not a system error or anything like that. You know, anyone can type the wrong thing. And so what comes back is, well, it was a user error. The client can choose to present this how nicely or rudely as they prefer. But the key point is that this guy, Bill's not there. Try again with one who is there. Now, if the application code itself got wrong and it somehow ended up sending ket instead of key in this thing, well, it'll break when it gets inside, obviously, because the inside can't unscramble it. And here, the reason that comes back is you gave me bad JSON. So I'm calling that a client code error. And the people in the client had better have the responsibility to turn that into something that doesn't frighten the end user. Like, you know, note this number and go to this website for a free gift. So then, now this is where I could have done the live demos, but I suspect I'm right out of time. So you must tell me.
I think, yeah, I think we're 10 minutes over, but do you want to do a quick demo? Maybe just a couple-minute demo, and then we'll
Okay, I'll do it. Thank you for the permission.
There's still enough people sticking around there, so
yes, good.
Yeah,
Why don't I just rock it through to the end and then go back to the demo? So here's the summary, and what are the benefits? As I hope I've already stressed, but the demo really brings it home. Correctness, that's the main thing. In my book, after all, there's no point in having something blindingly fast if it's wrong, except that is the modern trend, I know, but never mind. So correctness comes from this separation of skills and concerns, the metaphor of the gynecologist and the proctologist. You'd think the job teachers would be rather similar.
You know, at the end, everyone's just going to remember that metaphor and forget what it was you actually told them about. But anyways.
Yes. And then, you know, the right experts own their own components. I don't know how that funny thing got in there. And the coupling between them is terse, which is a good thing. And you've conquered data type safety this way. You're not dealing with a whole, you know, call interface C library that's got type mappings and all that complexity. It's just completely straightforward. And anything to do with manipulating the values is always done in the one homogeneous regime of SQL data types. And security, you know, controlled access to everything. The client can't do anything at all except call the intended procedures. And by the way, this gives you effortless and guaranteed SQL injection proofing, so you don't even have to talk about all that rubbish. And there are performance benefits, the minimization of client-server round trips, and you, by the way, get this prepare-execute paradigm without even noticing you're programming it. It all happens implicitly behind the scenes. And there we have it. So now I'll go over to the demo world. And first thing I'll do is just say, you know, Yugabyte Y yellow, Postgres P pink, and I've got them both ready. And I've got a big master script that if I run it, tears down the whole shooting match, builds everything from scratch, runs all the tests, and reports everything to a spool file. I've started it going there, and if I do the one with a P, the only difference is where the spool goes. It's the same payload in each case. That one's done. Let's see, that one's done too. So I'll go over here, I'll go to my GUI differ, and I'll compare the YugabyteDB spool with the Postgres spool. And of course, there are differences because I report at the start what version I'm in, and here I'm in the highly fashionable 2.15.01 YugabyteDB, and here I'm in the most recent Postgres, so they show these differences. For some reason, you know, owners in a laptop Postgres DB, the key system owners end up with the name of the guy who's the operating system user. God knows why that is, but never mind that. When you get down to the guts, there are cosmetic differences in the way that things are spelled. What I'm showing you here is the source code of some other procedure fished out from the database. This is all the stuff I created that implements the app. And then here we get to the test results, and the test results are identical in every shape or form, except in that this guy here is obviously, it's an automatically generated UUID. So every time you get that error, the value will be different. And then the wording of these things that come back in the messages that are created when you get exceptions, spell call in different case. Obviously, someone in Postgres whimsically decided to change lowercase to uppercase or vice versa at some point in time. Very strange. But the point is that, I won't say it again, Yugabyte and Postgres are absolutely identical. And then back to the actual demos, why don't I just then come in, I'll forget Postgres now, I'll go over to the app schema, I should say app user, give myself a clean start, come back to the client, and then do that, and then I'll do a positive test. I'll just insert something, and there it is. It's what I showed you on the screen. All that went in, and it was a success. And if I want to have a look, here's an ad hoc report not designed as part of the app, but just so I can show you something quick. And sure, there in ordinary SQL terms, we've got that. I don't know if you know this cunning way to look at the source code. Sorry, I always put D, not S, but I'll show it just to show all this is real. This guy here, no, that was not the one I meant. That was far too long to show you. I mean, this ad hoc guy here, I happen to know that it's got a text parameter. And there you have it. That's as short as you can get. And now you've seen a language SQL stored procedure who just is basically prepare, except you don't have to mess around with all that $1, $2 rubbish. It's modern programming where you name the parameters and you invoke the parameters by name down here. And then this is just one single SQL statement stuck between the opening and closing bracket that defines it, whose purpose is to do what it does and return it as a set of record with these two columns. And that shows that, as clear as it could be. And then if I do, blast through the whole lot here, the ones I hadn't done, and then blast that through, all success, and now do this query. Again, it's just going to do the big inner join on the, outer join on the whole shooting match. And there's the answer. Simple as that. And then if we go on and report one, let's report Mary. You've seen that before. There it is. It succeeded. And this is exactly what we want, all that shampoo and stuff. I don't know what Mary's thinking of, but there you go. And then let's put in the bad thing. It says, oh dear me, so I've seen it before. This one's more interesting. I've got two dupes in it. And I had to program for a couple of hours to get that, because the ordinary error you get when you do something, inserting a whole set of rows where there's more than one duplicate, is just hearing about the first one. My watchword is you program using huge effort to improve the usability. I know the modern paradigm is do the least as a programmer, go home and play your video games.
That was always the paradigm. That was always the paradigm. It's just you can do it now. You couldn't do it before.
Well, you can do it with effort. You can always do this with effort. You could have done this back in the day when I was first doing this. But anyway, there we are. I think I've done enough moralizing. Why don't I show just the one that really goes wrong?
Hey, Bryn, I think you're stuck, or I can't hear you. Or I'm stuck and everybody else can hear you. Okay, yeah, I think you paused, you cut out there for a little bit.
Am I back?
Yes, you're back. Yes,
okay. Oh, it says the connection is unstable. Anyway, I'm going to go over to the support engineer who can see these error reports, but no one else can. And there we, oh, sorry, it's too big to fit on the screen. But there you have it. So this is exactly what I showed you before. Christopher's the culprit and all that stuff. Someone who's deep into this can understand immediately. They can write back to the engineer who owns this unit and say, oh, look, you've got this. Nothing you can do about it, but we're going to have to report back to the client people. So you've got the ammunition now to do so. So there we are. I managed with those extra minutes that Karthik granted me to.
I think this was great. This was fantastic. So there's a couple of questions. I think there was one about nested stored procedures. I think Frank answered it, so I'm going to skip that in the interest of time. There's one unanswered question still. Perhaps we can close with that. This is from Marcus, which is coming from Oracle and written custom ETL code in PL SQL and PLPG SQL variant, and knowing the benefits of these when it comes to efficient managing huge amounts of data. Isn't one of the big disadvantages vendor lock-in and also lacking DB experts in dev teams? Usually those arguments push to classic ORMs like Hibernate direct on tables.
Yes, well, as you and I were chatting beforehand, Karthik, whoever asked the question, we're talking about gun ownership. We're talking about abortion.
Yeah.
The discussion doesn't yield to logic, except in
this is actually enabling a new paradigm of doing things, right? Kind of more so than just
to be brutal with you, Karthik, you're attempting the rational argument. But I know from long years of experience that there are some people for whom the rational argument never works. I will try now the actual canonical argument, and it's this. We already know that SQLs in each different database are not the same in dramatically different ways. Postgres has a Boolean data type, which of course any database should have. Oracle famously doesn't. If you come from Oracle using some text with T and F in one place and Y and N in another and so on, and go into Postgres, you'll be foolish to leave it like that. Going in the other direction, of course, you'd be stuck. And correspondingly, there are things that Oracle does, famously connect by, for example, in some queries, or a whole battery of built-ins that are exposed as package procedures, the like of which there's nothing in Postgres, but the functionality is often there. There's a ton of things you have to change, even if you're pure SQL. And you're changing it in a whole spaghetti, vast spaghetti of interconnectivity between client and server. On the other hand, if the application was defined by a well-articulated and perfectly well documented in external prose documentation API, then how hard is it to take that as the spec and re-implement it ab initio in the new environment in the optimal fashion? Okay, there are relatively straightforward ways of getting the data over. And if the data's there, I mean, you saw these procedures, they're typically not very big and anyone could write them in a short time. And that is the canonical answer. Instead of what you think, it's the opposite. If you follow the hard shell paradigm, you are making your best effort at vendor independence. Now, I know that some people are overwhelmingly convinced by it, and some people still think that
but I think the whole point
being at 1 million.
Yeah, I think the whole point is the flexibility that it offers, right? As opposed to, if you have it, you don't need to use it. If you don't have it, well, there just leaves you one choice. So
Yes.
Right. So cool, awesome. I think this was great. I think a lot of good interaction. Thank you, everybody. I think we'll just wrap up, given like we're almost twice the time, but it was still fascinating. And for all that, you shouldn't say you're not an engineer, Bryn. I think this was completely about programming languages and as well.
Yes. It's just I didn't write YugabyteDB. I'm going to come now with one last thing. Last time I put a message in a bottle and tossed it in the ocean. In other words, I zipped up all my code and put it up there as an attachment on the public forum. I'm not going to do that this time. I'm going to wait for someone to contact me on Twitter and say that they liked the presentation and they'd love to get all the code I had made. Then and only then will I zip it up, put it as an attachment on the Yugabyte public Slack, and tweet back to say I've done that. That's the deal.
Fantastic. So you guys know to reach out to Bryn. So, all right, that's Bryn Light, I believe, on Twitter. So, all right, fantastic. Thank you, Bryn. Thanks a lot. This was really awesome. A lot of good depth went into this presentation. So really, thank you. Thank you, everybody, for sticking around and asking questions and listening for even way past the time. We'll be back again next week. Same place, same time. Until then, see you guys. You can feel free to continue to ask questions on the LinkedIn comment thread here, or drop us a note on our community Slack. Thanks, everybody, and thanks, Bryn.
Thank you. Bye now.